Okay, everybody, it's 4:15. Going to get started. Good afternoon to everybody that's here. Thanks for being here. My name is Capen-Brinkley, and over here I have my coworker, Rick Mendez. We are software engineers at Intuit. Intuit makes a number of products, some of those being QuickBooks, TurboTax, Quicken, and Mint, among, that's a few of them. And the company's goal is to improve customers' financials lives so profoundly that they can't imagine doing things the old way. Now, our team in particular, mine and Rick's, we build automated solutions and web services that help Intuit hosting in AWS easier for Intuit products. None of the ones I just mentioned, but we have a number of other ones that are out there and using AWS today. So today, we're going to share with you how we leverage OpsWorks as the engine for our PaaS. In doing that, the high-level agenda, I'm going to cover how we even got into AWS, why we decided to do a PaaS, and why we chose OpsWorks as our engine. And then Rick's going to come up. He's going to talk a little bit about the architecture and the design, some of the decisions we made along the way as we were building this PaaS out. And then at the end, we'll have some Q&A for you, Q&A time for you guys. If you do have questions, if you can make your way to the mic and ask the question from there, that would be fantastic. It makes it easy. Everybody in the room can hear you, and we don't necessarily have to try to repeat the question if it's kind of a longer question. So, okay, so how do we even get into AWS? We have a product called Live Community, which is a questions and answers knowledge-based platform that is used by 17 Intuit products today. And you can kind of think of it as like a Stack Overflow or a Quora for Intuit products, but it's powered by our own team of engineers. And TurboTax is one of those customers, and they drive a really unique load pattern. And basically, we have two major spikes that happen, one in February, the other one happens in April. And how we used to do it is basically we would buy all the hardware that we needed just for those 2 months, and then for the rest of the year, 80% of the hardware would be sitting idle for 80% of the year. And so that group kind of spearheaded the way we use AWS today. So our team was actually spawned from development efforts to make the operations in the SDLC around Live Community highly automated. And since we had so much success with that, we were asked to help share our tools and practices with other Intuit businesses that we're trying to get to AWS. So why did we choose a PaaS, or why did we go the PaaS route? Well, our team is relatively small, and we had only about 3 people that were going around the company and doing this knowledge sharing. And we did this in a number of ways. So we had some brown bag sessions, we had monthly training sessions, and if a team was really serious about going to AWS and making a push towards it, we would have what was called an onboarding session. I'll tell you a little bit more about that in a minute. But no matter which method we tried, it basically ended up looking like this. So as you can imagine, we're that fire hydrant, and everybody else is that poor dog getting pelted in the face right there. It's one thing to go to AWS, and you have to learn EC2, CloudFormation, auto-scaling. It's kind of a new way of thinking about hosting in general. And then we go to groups and we say, oh, we have configuration management. We use Chef for that. And anybody in the audience who's actually deployed Chef, you know how fantastic it is, but you also know what the learning curve's like for that. So that's high in and of itself. And if that's not enough, we throw in our own open source tools and say, hey, we want you to throw this into the toolkit. So we want you to learn all this as well. So what it really turned out to is the trainings at best, because there's so much content, we're only scratching the surface. And even in the onboarding sessions, so basically what happened in those is we'd sit down with a group for about 2 to 3 days, and we'd do a little bit more hands-on. First day was kind of, we would sit, pretty much give them a presentation we'd do in like trainings, and we'd actually go through a test use case that actually got them using the tools and getting used to it. Second day usually started with them coming in and telling us about their architecture, and then we try to lay their application out on AWS. So this kind of started to make us have a couple of realizations. The first was being that this model was not scalable for our team, because we only had 3 people. We had a lot of groups that wanted access to us. We didn't have enough time to help them. Another thing I forgot to mention was, out of those onboarding sessions, it wasn't like 3 days and done. The groups would come back to us, and they would ask us, they would have to keep coming back to us to help them to the point where they actually got self-sufficient in using everything themselves. So that was more time off our plate that we didn't have towards focusing on our team and the other work we had to do. So the other one we realized is that, what I've pretty much depicted here is that tools are really hard for groups to consume and scale out, because they have to learn all this stuff if they really want to do that. And we were getting more grounded on, it's going to be a lot easier if we can provide some sort of service for them to consume. So they're learning the service. They're not learning the tools at that point. So that started getting us a little bit closer to PaaS. And then there was also one other unique thing that would happen. So I mentioned the onboarding sessions. Day 2, customer shows us their architecture, see what it looks like internally. They map it out to what they think it's going to look like in AWS, and we do any massaging of the application to get it out there if it's needed. So the customer would present their architecture, and what basically ended up coming out was they'd show us this. And we got the snowflake. And it was a beautiful snowflake, and it was fantastic. And everything worked great. We got them on. And then we'd go work with customer B a couple weeks later, and they would show us their architecture. Ooh, the beautiful snowflake. The only problem is they look very, very much the same. In fact, these ones are the same. Now, granted, the business logic may have been a little bit different with those applications, but everything else was relatively the same, including the infrastructure. And that got us even deeper into thinking, hey, you know what? We already know how to run large-scale applications using AWS. Why can't we just do something where they give us their code, and we run and scale the infrastructure underneath for them? Because really, that's the big deciphering factor between these guys. And so this is what really ultimately got us on the PaaS train and getting down that road. So why did we choose OpsWorks? Well, there was a number of things. We looked at a number of different solutions, and when OpsWorks was announced, we worked with the product manager, Chris Barclay, and the team. They came and showed us what they had, and we noticed a lot of things that were very similar to what we were doing today. We use Chef, they use Chef, fantastic. They were using a lot of AWS services. We were already familiar with running AWS services and what that took. And overall, the way they did things, they had a very similar operational model. Another thing that they had that we didn't have was they had a fully usable API that we could figure out a way to use. And they had a UI, so we said, OK, we might be able to leverage something in that. And lastly, they had more controls and compliance and security that Intuit needed for hosting any of our applications out there. As opposed to, we did look at Beanstalk, and we just didn't have the control we needed. So an example of those compliance controls would be, we'd be able to pump in additional Chef recipes that would harden the OS or do something of that nature that would allow us to have that compliance that we needed for the company. So that's why we chose OpsWorks. At this point, I'm going to hand it over to Rick. He's going to come in. He's going to tell you a little bit about the architecture and some decisions that we made along the way when we were building this out. So thanks, guys.
All right, good afternoon, everyone. Thank you, Capen. What I'm going to try to do is give you a little bit of insight on how we built PaaS v1, which is what we have in place right now, and maybe a little bit of a look ahead to PaaS v2. And the first thing I do want to talk about is the architecture. We built PaaS v1 on an API-driven architecture, and what we did is, around that architecture, we built a service-based application. The service-based application we refer to as the abstraction layer, and you'll understand more of that as we go along here. But the big thing with the API-driven architecture is, in our PaaS, APIs are first-class citizens. If there's anything I want you to get out of this talk, is we treat APIs as first-class citizens. And I've been on many projects where that was not the case, and that's why I want to stress that. And in our PaaS world, everything else you see today, everything else we talk about is just a client of the APIs. Now, with our abstraction layer being APIs, and OpsWorks having APIs, and all the AWS services having APIs, as we're developing this, there are some times where we just feel like we're buried in layer after layer of APIs, and we sort of feel like we're in this world. And just to give you an idea of how the different layers interact, we have our abstraction layer at the top. It contains all of Intuit's business logic. It contains any rules or with Intuit, any enterprise rules that we have to follow. And from there, it makes calls to OpsWorks to do many of the things it does. But we have many cases where it also has to make calls directly to the AWS services. Some people think we should be mapping one-to-one with OpsWorks, but there are just too many things, with IAM, S3, those kind of things, where the abstraction layer goes out ahead of OpsWorks and does things, or in some cases, it follows OpsWorks and cleans up some things for us. Next thing I want to talk about are some of the benefits we get out of the abstraction layer. And I know some people may be out there thinking, what the heck did you guys write an abstraction layer for? OpsWorks has APIs. OpsWorks has a web console. What more do you need? And then for some projects, that may be true. In our case, we got quite a few benefits from developing the abstraction layer. And there could be projects out there who would get similar benefits if you developed your own layer. The first benefit I want to talk about is nomenclature. As Capen mentioned, for a long time, our team has been out there building or deploying into our projects out to AWS. And during that time, we developed a consistent nomenclature for all the resources. And so when we started doing PaaS, we looked at OpsWorks, and OpsWorks had their own nomenclature for the resources. And so we had a decision to make. Were we going to offer our users two different nomenclatures, which would potentially confuse them, or are we going to offer them our consistent nomenclature and take care of it on the back end? So what we decided to do is the abstraction layer offers the same nomenclature that we offer outside of PaaS, and then on the back end, it maps to OpsWorks. This has been great for our users, but it's been hard on the developers. Sometimes you get a little confused when your layers are shuffling around like that, but our users have really appreciated it. The biggest benefit I think we get out of the abstraction layer is simplicity. As Capen mentioned, we were trying to find easier ways to get projects on AWS. And so with PaaS, that's pretty much its driving goal, is how do we take teams that may have little to no AWS experience in a situation where we don't have resources to handhold them all the way to AWS and get them onto AWS as fast as possible. So in terms of simplicity, we're talking API to API. As we showed in the nomenclature, our top resource is an app. OpsWorks' top resource is a stack. So what we can do, just as an example, is take a look at what's involved in creating our app API or creating our app versus creating their stack. And the first thing we notice is our API only takes 3 parameters. The OpsWorks API takes 16. Our parameters are just simple strings. The OpsWorks API takes more advanced elements than strings. And probably the biggest difference, to use our API, you need just very basic AWS knowledge. You need to know what regions are. The OpsWorks API, you need quite a bit of AWS knowledge to use it. And just as a visual for the difference in the simplicity between the two APIs, these are the inputs to those two APIs. The last benefit I want to talk about from the abstraction layer is flexibility. And this isn't so much from the abstraction layer itself. This is from the API-driven architecture. When you have an API-driven application, such as the abstraction layer, it's pretty easy to support any type of client. Everybody knows you can develop a web client against APIs, but it's really not that much more difficult to develop mobile clients or command line clients, or perhaps even integrate tooling such as Jenkins with the APIs. And we'll see an example later of how we use Jenkins with the abstraction layer. Okay, now I want to take a look at some of our use cases and the features that we worked on in version 1 and where we may be headed with them for version 2. The first is continuous integration. We have the ability with our PaaS to support continuous integration for any of the Intuit apps that we host. And as we'll see as we get through this flow, we can actually give them a bonus. So in this flow, a developer will do a commit on GitHub. A commit message will find its way to SQS, where Jenkins will pick it up. Jenkins will build the application. If the application build is successful, Jenkins will hand it off to our package manager. And our package manager has a decision to make. OpsWorks accepts tarballs and zips, so it'll be configured to upload one or two of the other. If he's just doing CI, he's going to actually call the abstraction layer to create a build. In our world, a build just stages a new version of code. However, if the Jenkins job has been configured to also do continuous deployment, after he stages the build, he will automatically call another API to actually deploy the latest code. And one thing I should mention is, much like Heroku, we do not support multiple environments within the same application. If you want dev, EDE, and production applications, or production environments, then with our PaaS, you'll actually create a dev app, an EDE app, and a production app. Okay. The next feature I want to talk about is application configuration. We're big followers of the Heroku model. And one of the things we like is how Heroku exposes configuration through environment variables. So we decided to emulate that within PaaS. And what we decided we needed was the abstraction layer needs its own set of system variables. Things like database configurations, caching configurations, anything like that, that it needs to manage the resources behind the scenes. But we also know that development teams need to be able to specify their own variables for different configurations our applications need that we would never think about. So the user variables come in from outside the abstraction layer. They get combined with the system variables from the abstraction layer. And as they're modified, we automatically write them to the OpsWorks custom JSON. Then on deploys, Chef reads them from the custom JSON and writes them to every instance as SDProfile.d files. For those who are new to OpsWorks, the custom JSON it's a JSON configuration that lives at the stack level within inside of OpsWorks. And when Chef runs, no matter what event Chef runs under, it has access to the custom JSON. The next thing that we worked on were instance statuses. Instances, while we were developing PaaS v1, we found that instances started up too slowly for our liking. And we believe that's going to improve over time. One of the ways we can help it improve is right now we use a very thin AMI, and we do everything within Chef. We're considering in V2 going to fatter AMIs to reduce the amount of Chef we run, just to speed up the startup times. But one of the problems with slow instance startups is it appears that the APIs are stalled when clients are using it. So we decided that what we had to do is present some kind of status monitoring so that at any given time a client would know what status the instance was in. So the flow here is a very simple flow, really. Start and stop requests come into the abstraction layer. And the abstraction layer writes a status message onto SQS. Now, in the background, we have this thing we call info manager. It's just a background process. And he reads the status messages off of SQS, and he starts pulling OpsWorks. And what he's doing is he's pulling OpsWorks for the latest statuses. At the same time, he's got a list of state machines that represent each instance that we're monitoring. If a status changes, he transitions the state machine for that instance. And this goes on until either the instance is online, the instance has failed, or the instance is stopped. And this is something we'll mention again later because, as we've talked many times with the OpsWorks team, this is one of the areas where we'd like to work with the OpsWorks team to actually improve startup times. The last use case I want to talk about is collaboration. We didn't actually develop this for V1. It was on our plans and never made it. But we do plan to do it in V2. And what we want to do is follow a GitHub model, where users belong to groups and groups belong to apps. In V2, what we plan to do is just do a coarse-grained model. So if you're in a group that has access to an app, you've got complete access to the app. As we get more users of our PaaS and start to learn more about how they use it, I think we're going to move to a finer-grained RBAC model in the future. This is one of my favorite slides because this lists the major technologies we use to develop version 1 of our PaaS. And as we looked at it, as we were getting ready for this session, we couldn't believe that we could develop a sophisticated application with so few technologies. And what we really think is that speaks to the power of using OpsWorks as the engine. We leverage OpsWorks in such a way that we just didn't need to develop, to use that many technologies to build what we built. And while we're patting Amazon on the back, I also want to mention the AWS SDK. When we first started working with it, earlier versions were a little rough around the edges. But we stuck with it. And recent versions are just absolutely fabulous. Our app rides it very hard. We make 1 million calls for this thing. And it's really helped us be successful. Node development goes without its challenges. And these are probably the top 3 from version 1. In the first one, think differently about your chef code. With all the chef work we do outside of PaaS, we use roles and data bags quite a bit. So it was quite surprising when we started using ops code to find out that they didn't support roles or data bags. And it caused us to really think differently about how we developed our chef cookbooks. The other thing that you may want to think differently when it comes to chef is, in our case, our team uses Chef Solo for everything, which is also what OpsWorks uses. So there was no learning curve. But if you are in a shop that uses Chef Server, you may have somewhat of a learning curve adjusting to Chef Solo. Polling for instance statuses, I already mentioned that we built monitoring around it. And what we would really like to see in this case is some kind of notification system. It's one of our hopes as we work with the OpsWorks team that, hey, we could get some SNS notification, this instance is up, that instance just went down, or whatever. But we'll see how that goes going forward. And like I said before, the instance statuses were the biggest thing that we coded around in version 1. The last one, the deletion of apps, was an easy thing to code around, but it was kind of surprising. When we first started deleting apps, we figured, hey, it's a piece of cake. All these resources are connected. We'll just say, delete that app. We'll go back to OpsWorks and say, delete the stack, and it'll delete everything. We found that didn't work. What OpsWorks wants you to do is stop your instances, delete your instances. Now you can go back to your stack and delete everything. So like I say, it was easy to code around. We jump out and take care of the instances first. Then we go back to our own app resource and delete all the way down. Like I say, that's a minor thing, but it was just one of those things that surprised us. Looking ahead to V2, we actually have Java support in V1, and we built it from scratch. But last week, OpsWorks went ahead and released their own Java support. So anytime we feel that we have some kind of duplication of effort, we're going to have to sit down, take a look at the OpsWorks offering, compare it to what we did for our custom chef code to support Java. And if we find out that OpsWorks does what we did or does it better, we're going to throw our code away. Because we're a small team, and there are other places we can spend our resources than maintaining code that OpsWorks already provides. Application visibility is something we did not touch in V1. A lot of times within Intuit, we'd sit down with groups, and one of the first things they'd ask us is, if we give you control of our app on PaaS, how do we know what's going on? And we said, don't worry, we'll take care of it. The problem is when you're trying to get PaaS off the ground, it sits out there as this big looming thing, and we just never got to it in V1. But I can tell you that my architect has told me that in V2, this will be a main focus of PaaS. And what we mean by application visibility is we want customers to be able to view their logs, download their logs. We want them to be able to view runtime introspection of their applications. And now that we're at this conference, perhaps we even want to hook up CloudTrail and parse some of that logging to show all the API calls that they're making. Additional languages and frameworks. We currently support Ruby, Ruby on Rails apps, Sinatra. We support Java with Tomcat. We're talking about supporting Java with JBoss. But we get requests for a lot of other things, and probably the #1 thing that comes next is WordPress. I don't know how many people have talked to us and said, hey, PaaS seems like the perfect place for our WordPress site. And before we leave this slide, there's a couple other things that I think we're going to look at in V2. Collaboration is definitely one of them. In V1, we basically went with the simplest model we could. And so there's no doubt we need to get the coarse-grained collaboration in there for V2. And the other thing is, as we manage instance statuses, there's one monitoring that we left out, and that's deployments. You'll notice when we run the demo later on that inside of the web UI we have, there's no way to tell what happens once you start a deployment. And that's a hole, but it's not a big hole, because we can model what we did for instances for deployments. And deployments, again, it's not like instances are many minutes to start up. Deployments are a minute or two, so it's not as big a deal, but it would be cleaner if we actually monitored the status of deployments. So I think we'll take care of that in V2 also. All right, so what we want to do is show you a quick demo of what we have for PaaS V1. And one of the things I'll tell you ahead of time is that we have no UI experts on our team. So don't judge the abstraction layer by the look of the UI, please. It's a very simple UI. So the first thing we need to do is to create an app. And like I mentioned earlier, it just takes 3 parameters. We give it a simple name. In our case, for the demo, we're going to create a Rails app, and then pick the region that you want it in. Once you have an app, the next thing you want to do is create stacks to represent essentially the technologies and the layers that you want. So in our case, we'll want a Rails stack for an app server. And the other thing we're going to provision here, as we'll get to, is a MySQL stack. Now, any of you Intuit people out there, I don't want you to panic. We ask you to tell us that you want to provision MySQL, but don't worry, we manage MySQL for you. You don't have to manage it. So once we have stacks, now we're going to create instances and start them. And because of the length of time for the video, we've collapsed the startup of the stacks. So these are going to look pretty quick, but the only thing I want you to notice is that you will see the states of the instances change as the video goes along, and that's from the monitoring. So there we went from stop to requested. I think we let this go to pending, and then we time collapse it into a started instance. Once the MySQL instance comes up, we have all the information about that instance in the system variables. And so the JSON's been updated, all the instances have been updated with the config. We know the database name, we know the user, the password, the database endpoint. So it's all available for Rails or Java, depending on what you're deploying. Okay, now that we've got instances, the next thing we want to do is stage some code. So with this simple app, we're not doing CI or CD, so we're going to manually create a build. And again, in our system, a build will just stage code to S3 that OpsWorks can grab. And OpsWorks will take a tarball or a zip, so in this case, we'll upload a zip. So the next thing that we'll see is we're going to create a deployment. And again, because we don't monitor deployments, you're going to see the video go up to the OpsWorks console to see how the deployment ran. And that's why I say in V2, we're going to integrate the deployment monitoring into the app. Oh, sorry, before we do the deployments, we're going to do a user variable. And with a user variable, just pay attention to the value because we'll see it later in the demo. And again, once this is added, it automatically goes to the OpsWorks custom JSON. And so all this will tell us is, in this case, with this Rails app, we really only need to go to the Rails instance, but in the demo, we show you we can deploy to both. And so all we know now is that we've created a deployment. So we have to go up to the OpsWorks console. We can see it was successful. And the other thing we'll show in here is, for all of our app instances, we put an ELB in front of them. So we're going to, on the next part of the video, we're going to grab the ELB endpoint so that we can try to hit the app. And there we go. That's the live app pulling the OpsWorks' cool user environment variable from the Etsy profile.d. So we want to thank you all for coming. We hope you enjoyed the talk, and we'll open it up to questions.